Bismillah ar-Rahman ar-Rahim. I'll continue doing this 7.2. So this is like a summary, then we'll do all the exams problems. And we explain the problems. Now just have the summary, and then we'll do all the exam problems. Okay. So what is the idea? You have a solid that lies between two lines. Okay. If the cross-sectional, if they have a cross-sectional area, and then the volume will be the integral of that area. So how to calculate the volume of that solid? You need to sketch the solid and a typical cross-section. Usually we have many cases, but let me talk about 3 or 4 cases. If you have squares, then I know the area is the, what do you call it, the length or x square. If you have equatorial triangle, then it will be the area will be square root 3 over 4 x square. If you have semicircle, this is the x, I mean the base, huh? Semicircle, then the area is pi over 2 area r square. These x and r, these are the base. Only in this case, 2r will be the base. And I have x is the base. And I have x is the base. Okay. As I said, except this one, I have the base is 2r. So first I need to find r, which is the base over 2. Then I plug it here. Then I find the semicircle. Then find the volume of the area. It depends on the cross section. As I said, sometimes we have squares, equatorial triangle, semicircle. These are the, and maybe other shapes, but these are the 3 main shapes. Find the limits of integration, then we just integrate, finding the volume. Now also we have if we are doing a region where the rotation is about a line parallel to the x-axis, y equals 0, y equal 2, y equal something, then the volume will be in terms of x. You have a of x dx. If you have the rotation is about a line parallel to the y-axis, x equal L, x equal 0, x like the y-axis or anything parallel to the y-axis, then everything in terms of y. And also these c's and these, they are the y between c and d. Huh? Here I have x between a and b. This is about the limits of integration. We have 2 ideas, disk or the disk is just pi of the radius square, which is I need to find capital R of either x or y. It depends. The rotation is a line parallel to the x-axis or y-axis. Then we have a disk and we have the washer, where I have an outer radius and inner radius. I don't have only one radius. I have 2 radius, one outer, one inner. And then we have pi outer radius square minus pi outer inner radius square. Like if I'm doing the outside volume minus yeah, just there is a hole in the middle. So I need outer radius and inner radius. Okay, let me do these problems. The volume of the solid obtained by returning the region closed by the curve. I have the curve. It's always good to graph the function. So let me just graph the function. What I will have y equal x minus 4, square root x minus 4. That is the function. Let me do this one. So this is my function. This is the x-axis, this is the y-axis. And what is the region? When taking the region, first you need to sketch the region enclosed by the curve. This y equals 0, which is x-axis. This is y equals 0, it's the x-axis. And x equal 8, which is this one. So I'm talking about this region. Okay. And I will take my the strip is, oh no, what about the rotation? Yeah, it's the rotation about the x-axis. This is the rotation about the x-axis. So take the line or the strip perpendicular to the axis of rotation, which is this one. Okay. So now I have what? I have only uh one volume or one radius. So I have capital R of x will be upper minus 0 square root this is y equals square root x minus 4. This is y equals 0. So I have square root x minus 4 minus 0. Okay. I have only this, huh? So I have this case. I have this there. This where I have r of x also. Okay. So what will be the area? The area will be by r square of x, which is by x minus 4. And now what is the volume? The volume will be from where to where? I put this strip there. So I have it from 4 until 8. From 4 until 8. And this is the area by x minus 4 dx. Okay, let us do the calculation. I have by, what's the integral of this? X squared over 2 minus 4x. And I want to do this from 4 to 8. That gives me by 64 over 2, that is 32. 8 times 4, this is 32 again, minus. Now 4, 16 over 2, that will be 8 minus 16. So that is 0. This is 0. This is minus 8 minus minus. So that'll give me 8 pi. And that will be the answer. Okay. I'm doing it. I'm trying to do that in detail. Yeah. The amount of energy generated by revolving the region in the first quadrant. It's in the first quadrant. I don't know how to graph the function, but I know this is positive. And between x equal ln 4, this is x equal ln 4, x equals 0, which is the y-axis, and this is the x-axis. I'm function here. I don't know what it will do. It will be something like this. Yeah, I know it's in at cosine hyperbolic 0, it's 1, huh? Cosine hyperbolic at x equals 0, it's 1, so something like this. I don't care. Yeah. And it's doing up and down, but it's going like this. It seems to be yeah. I know the exact graph, but I know it's something like this. Okay, about the x-axis. Okay, so what will happen? I'll do the strip. This is my line. So it will be r of x, and it will be the function minus 0. And what is the area? Will be by r square of x, and that is by cosine hyperbolic x over 2. And from where to where? From 0 to ln 4. So the volume will be from 0 to ln 4. I don't know the graph of the function, but I'm just thinking of it. It's positive. So it will be something here. I don't know what it will do. Okay. So it will be by cosine hyperbolic x over 2 dx. That's it. So I have what? This is by how to integrate cosine hyperbolic. That is sine hyperbolic x over 2. Because of that, I need 2 here. Okay. And from where to where? From 0 to ln 4. So I have 2 pi times what? Be careful. Times sine hyperbolic half ln 4 minus sine hyperbolic 0. I know sine hyperbolic 0 is equal to 0. This one half will go as a power. So this is ln 2. So that will be 2 pi E ln 2 minus E is minus ln 2 over 2. That gives me pi of 2 minus half, because this will go as a power. So it will be 3 pi over 2, which is this. Okay. The volume of the solid obtained by rotating the region closed by the curves x equal y square, y equal x cube about the x-axis. Okay. So this is the function. And we first need to graph the two functions. This is this one, and this is something like this. Okay. So what is the region enclosed by this? I'm sure I'm talking about this region. Talking about this region. Okay. So do my line. Oops. This is the line. This is the other one. Yeah. So in this case, this is my line. So I have an outer radius and inner radius, because this is, it's like I'm finding this. I mean, doing the volume for. Let me explain it this way. Let me use this. I'm doing this minus this. Okay, I'm doing for this one minus this one to get this one, to get the one in the middle. Okay, so I have an outer radius. What will be the outer radius? By the way, it is actually this is about x-axis. So you have it r of x. R of x, which is the outer radius, will be this one. But this is, I want it in terms of x. So I need to write this y equal plus or minus square root of x. But I want only the positive one, so I have square root of x. And the small one will be what? X cubed. Okay, now I have the outer and the inner. Okay, so what will be the volume? Green. And from where to where? Also from where to where? Yeah, I can equate them. It's very clear. It's from 0, that will be 1. Yeah, square root of 1 and 1 cube. That's very clear. It's 1. They intersect at 1. Okay, so the volume will be integral from 0 to 1 pi times this one square, or let me say the area. The area is what? Pi outer square minus inner square. Outer radius square, which is y x minus x to the power 6. So that will be x minus x to the power 6 dx. So you have pi, what's the remaining? X squared over 2, x to the power 7 over 7 from 0 to 1. That will be pi half minus 1 over 7, which is what? 5 pi over 14. And that the minus is generated by the following region bounded by the curves y equal ln x. This is y equal ln x. And this is y equal x. They will not intersect. Okay. From x equal 1. X equal 1, it's here. I do it in. I usually do. Yeah. This is ln x. And this is y equal x. And this is at x equal 1. Because I know ln 1 is 0. So this is x equal 1. And this is x equal 4 somewhere here. So we are talking about which region? We're talking about this region. This is my region. Okay. This is my region. And they wanted the revolution above the line y equal -1. So I have the line y equal -1 somewhere. And I have the revolution about this. About this line. Okay. So I'm talking about, yeah, I'm talking about this. This is what I'm looking for, but about this line. So I want to find this up to here minus this, oops, up to here. Yeah. So I have r of x will be what? This is the upper one, the outer radius. That will be the function x minus -1. That will be x plus 1. And the inner one will be what? Will be this ln x minus -1, which is 1 plus ln x. Okay. And from where to where? From 1 to 4. That's very clear. So the volume will be 1 to 4 pi, let me write pi outside or inside, who cares? R square, this is square, so the area, let me write the area, pi R square, this is the area, R square minus the small r square. That give me what? Pi x plus 1 square minus 1 plus let x all square. Let me do the calculation. Let the pi outside. That will be x square plus 2x plus 1. Okay. Minus 1 minus 2 ln x minus ln x square. So the 1 cancel with the 1. And they have what? Pi, don't forget the x. Pi 1 to 4. I have x square minus ln x square plus 2x minus 2 ln x. I'm try to write it the way he wrote it, which is this. Okay, so notice he does not ask me to find the total volume, just the formula. Let's write it as a formula. Given by this integral. Okay. I now I have something where the cross section is semicircle. So I'm talking about these cases. I'm talking about these cases. Okay, and especially the semicircle. Okay. Let me graph the function, graph the region. What we have, y equal x square. This is the base, y equal x square, y equal 2x. Yeah, let me make it a little bit bigger. Yeah. Let me write y equal to x. Let me have the number like this. Okay. In the first quadrant, you want in the first quadrant. خلاص, I am here. So for sure, my strip is this one. That's it. Okay. So this is my line. This is my base. The base is the region bounded by this. Okay. If the cross section of like that, semicircles. What is the area for the semicircle? Pi over 2 r squared. Don't forget, with diameters running across the base of the solid. He make it clear now. So the base of the solid, what is the base of the solid? The base, in this case, it will be the line, which is 2x minus x squared. That will be the base. 2x minus x squared. Yeah. Yeah, the line is 2x. Okay. And from where to where? From 0. So I need to check 2x equal x squared, point of intersection. That means I have x squared minus 2x equals 0. I have x times x minus 2 equals 0. So I have x equals 0 and x equal to, or x equal to. So it's from 0 to 2. Okay. And this is my base. Don't forget. Remember when I talk about the semicircle, I said the base is 2r because the base will give me the diameter. So it's 2r, not r. So this is equal to r. So that implies r is what? R will be x minus x squared over 2. That will be. So what will be the area? The area will be by r squared. X minus x squared over 2 all square. Okay, so what is the volume then? The volume will be integral from 0 to 2. Yeah, by the way, the cross-sectional is perpendicular to the x-axis, huh? Perpendicular to the x-axis. So I'm dealing with in terms of x. It's perpendicular to the y-axis, I deal in terms of y. Okay. What's this here? It is perpendicular to the, yeah, perpendicular to the x-axis, I deal in terms of x. Perpendicular to the y-axis, I need to deal in terms of, okay. I'm doing it in details just to be sure that we understand it very well. It's my circle now. That will be by it outside. This is square. So I have x squared minus 2x x squared over 2 minus x to the power 4 over 4 dx plus, I mean, that will be by from 0 to 2 by over 2. Don't forget the area is by over 2. So I need by over 2 here. Sorry. That will be 2. I have by over 2 here. Because the area is by over 2, not by. This is my circle. This one will be, I can write it the way he wrote it, x to the power 4 over 4 minus this 2 with 2 minus x cubed plus x squared dx, which is, this is the answer. Okay. The volume of the cell is generated by rotating the region closed by the curve. Okay. What's the curve? Y equal 2 over x. This is 2 over x. Y equal 0, which is the x-axis. X equal 1, x equal 4. 1 to 4. Rotating about what? X-axis. So I have my line. This is my region. I have the line perpendicular to the x-axis. So it will be, will be my line. Okay. I have only one function. So I have r of x with what? The function minus 0. The length of this is y, which is 2 over x minus 0, which is 2 over x. So what is the area? Will be by r squared of x, which is 4 pi over x squared. So what is the volume? The volume will be from 1 to 4 by r squared. Oh, yeah, which is 4 over x squared dx. We'll do the integration. That give me what? Minus 4 over x from 1 to 4. That give me minus 1 minus minus 1. That give me 3 pi, which is the volume is originated by rotating the region closed by the curves This is y equal x square, y equal 1 minus x square, which is 1. This is going like this. This is 1, this is minus 1, this is 1. Y equal 0, which is the x-axis. So this is the region. So this is the region we're talking about. Talking about this region. Okay. And avoid the line y equal 2. I want it to be about the line y equal 2. This is y equal 2. So for sure, I will do the strip or the line this way, perpendicular to the axis of revolution. This is my axis of revolution. Okay. So I'm talking about this. And this is my axis of revolution. Okay. So what will be? You have what? You have r of x should be what? When you rotate this, there is something in the middle here. Huh? I have something here. So, because this is how to get this? I'm rotating this, but about this line. About this line. So I have the upper radius is 2. This is my upper radius. This is my upper radius. 2 minus 0. And I want, now what? I want this. So this one is this upper one minus this one. Minus, yeah. Trying to think a bit about line to see the outer radius. So this is will be my inner radius, and that will be the outer radius, the bigger one. Maybe this is a way to think about it. And this is the inner one. So r of x is what? This line is 2 minus the function. 2 minus 1 minus x squared. This one, talking about this one. 2 minus this, minus the function. So it will be what? 1 plus x squared. Yeah. So it will be my area. My area will be by r square minus a small r squared. Let me go right away to the volume. And the volume from where to where? The volume, yeah, is from 0 to 1. From, no, from minus 1 to 1. All of this. So I'm going, yeah, I can put the strip here and place, okay. So it's minus 1 to 1. The volume will be minus 1 to 1, and I have by here r square, 2 square, which is 4, minus small r square, which is 1 plus x square all square dx, which is clear. Okay, so that give me by of what? Let's do the calculation first. 4 minus 1 minus 2x square minus x to the power 4 dx. So that will be 3x minus, yeah, it's an even function. So I can say this is 2 by from 0 to 1 of 3 minus 2x square minus x to the power 4. Yeah, to save calculations. That give me what? 2 by 3x minus 2x cubed over 3 x to the power 5 over 5 from 0 to 1. So I need to substitute the 1. That will be 3 minus 2 over 3 minus 1 over 5. That will be 2 by, what is this, 15? Yeah, 15 times 3, that is 45. 15 over 3 is 5, minus 10, minus 3. So I have what? 2 by, this is what? 32? Yeah. 45 minus 10, 35, minus 3, 32 over 15. So that gives me 64 by over 15, which is this one. The volume generated by rotating the region enclosed by this line y equal ln x equal e, x equal e, that is x equal e, and y equals 0, which is the x-axis. So I'm talking about this region. Talking about this region. Okay. And you want to rotate it about what? About the y-axis. Well, this is my axis of revolution. So I want to put my line perpendicular to this axis of revolution. So I need to make it this way. So this is my line. Okay. So I have, yeah, to get this line, I need the upper one minus the small one. So I have r of x, r of y is what? E. This is the upper one. Small r of y will be what? Will be the function in terms of x, in terms of, yeah, in terms of y. So this is x e to the power y. So I have e to the power y, which is clear. And what is the area? The area will be by e squared minus e2y. Okay, so it is the volume. The volume from where to where? From, this is the terms of y. So this is 0. But this is what? This is x equal e, but y equals what? 1. So y equal 1 here. So I have from 0 to 1, because I'm doing the integration in terms of y. 0 to 1 by, let me list the by on this side. I'll put it here, no problem. E squared minus e2y dy. Yeah, so I have by, yeah, I can do the integration right away. This is e squared, just a number, times x minus half e2y from 0 to 1. Yeah, do the calculation. That give me what? E squared minus half e squared. Okay. Substitute the 0, that will be 0. Here I have what? Plus half. Minus half, which is plus half. So I have what? By half e squared plus half. So I can take 1 over 2 outside. So I have e squared plus 1. And that is the answer. Okay. The volume of the solid obtained by rotating the region bounded by the curves y equal minus x. Here I have y equal minus x. This is y equal minus x. And y equal x squared. And y equal x squared. Okay. So I'm talking about which region? Talking about this region. And this is my line. And rotation about the x-axis. It's rotating about this, the x-axis. Okay. So it's like I'm doing, this is the upper, and this is the lower to get this. Yeah, but inside, can you think about it like this? this one minus this one to get this one. Yeah. Oops. Okay. Yeah. So I have capital R of X will be this one, which is minus X. Small r of X will be this one, which is X squared. From where to where? I need it. This one, I know it's minus 1, and this is 0. So from minus 1 to 0. So the volume will be, and the area will be what? Will be by capital R square, which is X squared minus X to the power 4. That will be the area. So that will be by from minus 1 to 0. X squared minus X to the power 4 dx. That give me by X cubed over 3 minus X to the power 5 over 5 from minus 1 to 0. If we do the calculation, that will be by 0 minus 0, that will be 0 minus, like this one, minus 1 over 3, minus 1 over 5. That will give me plus 1 over 5. So I have by of what? This is minus 1, minus 2 over 15. So it's 2 pi over 15. Should be positive. Okay. The base of the solid bounded by this parallel to cross-section perpendicular to the y-axis. So everything there's are semicircles. What's semicircles? Okay. So everything should be in terms of y, not in terms of x. So I need to deal with this as x equal ln y. Okay. Now let me see what will happen. How to grab the function and see what will happen. Okay. So this is y equal ex, x equals 0, and y equal e. At 1, at x equal 1, it's e. So this is y equal e. Okay. So I'm dealing with this one, since it's perpendicular to the semicircles. Perpendicular to the y-axis, I mean. So it should be something like this. Okay. What is my base? The base will be what? The function minus 0, but in terms of x, huh? In terms of y. So it will be ln y. Okay. Don't forget, 2r is the base, which is ln y. So r is ln y over 2. That will be my r. So what is the area? The area will be pi over 2 r square. And that will be pi over 2 ln y over 2 all square. That gives me pi ln y square over 8. And that from where to where? I'm talking about the y values. The y values, I need this value. This is E. I know this is E, but this is what? This is 1. So it's the volume will be 1 to E, the A of y dy. And what is my area? It's pi over 8. So let me take pi over 8 as a constant outside. And then y all squared dy. Which is the answer? Okay. The volume of the solid obtained by rotating this region about the line, about the y-axis. I think this is not that difficult. Let me graph it. about the y-axis. Be careful, not the x-axis, the y-axis. So I have y equal x square and y equal minus x. This. And I want this about the y-axis. My axis revolution is the y-axis. This is my axis. So I will make my line like this. So everything in terms of y. So to do that, I have the outer, which is this one, minus the inner, which is this one, to get this one. So I have r of y, yeah, and it change everything in terms of x. I have x equal minus y, and I have x equal square root of y with a negative sign. Minus square root of y. Taking the negative, it will not make a difference, but it's okay. So what is r of y, capital R of y? The outer is the parabola. So it will be minus square root of y. The inner is the line, which is minus y. So what is the area? The area will be by the outer square, which is y minus y square. And from where to where? This point is what? Yeah, I want the y values, huh? The y from 0, this is minus 1, but the y value is 1. So the volume is by 0 to 1 of this y minus y squared dy. So it's by y squared over 2 minus y cube over 3 from 0 to that give me by half minus 1 over 3. That give me what? 3 minus 2 by over 6, which is this. The volume of the solid by rotating the curve, let me graph the function. The region under the curve, this, and x between 0 to y. So I have this function, sine from 0 to y. It's what I need. And about what? About the x-axis. About the x-axis. Okay, so my line, well, my strip will be this one. This is my strip. Perpendicular to the axis of revolution, which is the x-axis in this case. So I have only r of x will be what? 2 sine x minus 0, which is 2 sine x. So the area will be by times this square, which is 4 sine square. Okay, so it will be the volume. The volume will be by that from where to where? From 0 to by 4 sine square x dx. That will give me 4 by from 0 to by sine square. I can rewrite it as what? As half minus half cosine 2 theta, using the double angle for cosine. I know the cosine 2 theta, yeah, is 1 minus 2 sine square theta. 2 sine squared is equal to half minus half cosine 2 theta. Okay, so that give me 2 by from 0 to by 1 minus cosine 2 theta d theta. Do the integration now. That give me theta minus half sine 2 theta from 0 to by. That give me 2 by log by, that will be by sine 2 by 0 minus 0 minus 0 0 خلاص. That will be 2 by square, which is this one. Okay. We do more problems. are the region bounded by the lines y equal plus 1, y equal 2, and if on the rotation about the line y equal minus 1. Okay. Yeah, let me graph the region. I have y equal x plus 1, which means what? At 0, it's 1, and at minus 1, it's 0. So it will be this. Okay. And they want it from where to where? Y equal to, this is 1. So this is y equal to, y equal to, and the x equals 0, which is the y-axis. When you say x equals 0, you mean the y-axis. So I'm talking about this region. Okay. And they want it what? About the line y equal minus 1. So this is my axis dimension, which is minus 1. Okay. And I want to do my strip perpendicular to that. So it will be this one. So it will be what? It will be, think about it, this one minus this one. So capital R of x is 2 minus minus 1, which is 3. Small r of x, the line, which is x plus 1 minus minus 1. The line minus minus 1. So it will be x plus 2. Okay. And from where to where? I want this, x equal to this one is x equal 1, huh? When that is equal to 2, at x equal 1, y equal to. And the point of intersection between these two functions, huh? Which is very clear, this point, which is 1 and 2. So I have the integral. Now, what is the area? The area will be by 3 square minus this square. No, it's a matter of calculation. No. So it's by integral from 0 to 1, 9 minus x squared minus 2x minus 4 dx. So that will be by, what is this? 9 minus 5x minus x cubed over 3 minus x squared from 0 to 1. That will be by 5 minus 1 over 3 minus 1. Yeah. Minus, yeah, sorry, this is 4x. Yeah, over this is x squared plus 2 times 2, that's 4x plus 4. Yeah. So 4x. So this is 2x squared. So this is, give me minus 2. So it's by 3 minus 1 over 3, which is 8 pi over 3. 9 over 3 minus 1 over 3, 8 over 3 times pi. 8 pi over 3. Okay. The volume originates by the region closed by the triangle. I need first to graph the region, which is nice. Nice region. Let us see what will happen. What is the region? I know 1 and 0. This is the point 1 and 0. This is the point 2 and 1. And they have 1 and 1. So talk about this triangle. My triangle. And about what? About the x-axis. Okay. So I want my strip is like this, or my line. Okay. So I have the upper one. This is the upper one. By the way, this line is what? Y equal 1. Huh? This line y equal 1. This line. And the small one, which is this one, to get this one. So I have capital R of y is 1. Now, to find the small one, which is this line, yeah, I need to be careful. Put it in a different color. Yeah, I have this one, the green one. The green one passing through what? The points 1 and 0, 1 and 0, and 2 and 1. So find the slope. The slope will be 1 minus 0 over 2 minus 1. The slope is 1. Okay. So what is the line? I have the point and a slope. So the line will be y minus 0 equal 1x minus 1. So it's y equal x minus 1. And that will be my small r. Yeah, make it a different color just to be. Now go back to the blue one. I have the area will be y 1 square minus x minus 1 square. خلاص. So it will be the volume. Yeah, from where to where? Yeah, it is from 1 x values from 1 to 2. From 1 to 2. That will be 1 to 2. This by, you can put the by outside. 1 minus x minus 1 square dx. So it's by 1 to 2. You have what? 1 minus x squared minus 2x, it will be plus 2x plus 1 minus dx. So 1 with minus 1 gone. I have by, you have what? X squared minus x cubed over 3 from 1 to 2. Yeah, that give me what? 4 minus 8 over 3 minus 1 minus 1 over 3. Yeah, that give me by 4 minus 1, that is 3. Minus 83 plus 73, that's minus 7 over 3. Which is what? 9 minus 7, 2 pi over 3. Which is this. Okay, nice. Yeah, I think I will, yeah, I think I will stop here. Yeah, we have good number of questions, and I think we covered most of the ideas. So let me stop the recording, and I will do more recording later. Thank you.